So let's start our data structures lecture on, well, today we will talk about classes and objects in C++. So again, one of the big ways of abstracting, of creating abstractions, of structuring your code. So I assume, of course, some of you have, most of you probably have used classes and objects in Python, right? Of course, since Python is OOP language. Probably, well, C is not OOP language, right? JavaScript is not really, sort of, right? So, but C++, of course, is the big thing why C++ became popular is because, of course, it followed the idea of class and well, objects. And so what's the big idea, right? It is about creating abstractions, or well, I usually say this car, right? We have some idea of something, right? And the idea is we have a way of combining data, like in this example, fuel and max speed. Also, we have methods. In the case of C++, it's going to be member functions, right? To do something with that data. So we combine data and functions that work on this data together. And we provide a template or a blueprint for this. That's what we call a class, right? And when we use this class template or blueprint, we create instances, and we call them objects. Basically, they are specific ones which contain this data and actually will contain also the methods. And again, I say methods, of course, that's what we use in Python, but in C++ we call them member functions. Again, both of those are used interchangeably depending on the language, right? So attributes, fields, right? Properties also sometimes. In fact, we use structures in our last lecture, right? Actually, it turns out that structures in C++ are very, very similar to classes. The only big difference is, of course, the structures have public access by default, classes have private, right? And we can publicize them. But we'll talk about that in due course, right? Of how we get our data. So let's see what the slides say, right? Private protect the public. We'll explore the implementation. Of course, we'll probably want to talk about constructors and destructors, right? So idea, of course, is this abstraction, right? ADT, abstract data type. Basically, we say, okay, here's some data. There's something we can do with this, right? Some operations we can define basically on a piece of paper or on a blackboard or whiteboard. We can write what we want to do, what we want to store, but we leave the details of implementation for the actual whoever wants to implement it, right? So as a user of this ADT, we don't care what's underneath, right? We just want some guarantees it works, right? So, in fact, we use ADTs all the time, right? We use some things like vectors, we use stacks, we use queues, things like that. We should not really have to worry about how they're done underneath, what kind of magic, what kind of optimizations are done, as long as they work, right? So we are hiding this complexity. We're creating abstractions, basically, right? So information hiding. Again, ideas. Too much knowledge might be too dangerous, right? So, of course, the problem is when these abstractions leak, right? And they leak, and there's some details you have to know. Unfortunately, that's almost always the case. It's almost impossible to get perfect abstraction, like when you don't know anything about, you still eventually need to know a little bit what's happening underneath, eventually. So, let's get started. So, OD or OP, right? OD is basically, well, we model our world in objects, right? And we try to make some generalizations about this. So that's a big design methodology, right? How we create our programs, larger projects. And again, the thing is, it works pretty well for many things, but sometimes it doesn't work, right? And again, it's not the only way to do it, right? But let's get to some syntax and let's create our first class, right? So we identify, and then we say what's going to be inside, basically, right? So that's our syntax for defining. So let's get started. Let's go to our CPP, data structures repository. And again, you can, if you have a login, you can open up your own code space. Mine is cuddly space fork. All right. And let's see if Visual Studio Code is how it's doing this today. While it's setting up, we can keep going, right? So we probably want, again, so idea is we're not only going to be declaring some data in our members list with some ID, but also most likely have a member functions, right? So again, we are not declaring the memory allocation, right? And again, of course, this you have to be careful. Maybe there is some things about static, maybe something depends on the language. There are many different OP languages, right? I don't want to be. Don't trust the book completely. I mean, the book is not horrible, it's not bad, but it's not complete, right? So, okay, there's my namespace. All right, let's see, do we have Copilot? Of course, I'm going to want to reload the window for Copilot since I'm lazy. And now, let's see, classes, CPP reference. So what do they say about the memory? All right, user-defined type, again, right? And again, data members, member functions, and actually now it allows also nested types, right? So it actually gets more complex, but for now we just talk about these two things: data, right, and member function. That's what for now we are focusing on right now, right? So again, this is a little bit too much. This because of course there are different implementation details, right? And so plain old data, right? So class declaration. That's what we probably want to see how to write it, right? Class matrix, class vector, right? So we can also probably, again, use our own. So let's do this. Again, for now, skipping namespace. Let's do classes. Classes CPP. So now let's explore classes and objects in CPP. Right. So class is blueprint for object. Again, that's always a blueprint, right? Rasējums in Latvian, right? So yeah, so that's an idea, right? So again, so I assume you all have used classes and objects, right? So it's kind of like just repeat, right? So yeah, and of course object is instance of class. But again, just in case you forgot that, right? So let's see how, yeah, include IOStream. Now we can let's use namespace. Let's use standard namespace, right? Since you're lazy, and now we can define a class. So what are we going to do? Well, no, that's boring. We'll do a class of, but probably, do we want person or let's define a class animal, right? Right, very generic class. So, oh my God, it's too much. Maybe very basic, very for now, very basic. With few properties and few methods, right? And of course, you probably want to do too much. Of course, right? So, private string age and well, this name, set age. This is getting too much actually already. We'll do this in a moment, or maybe we'll just go through it all of it, right? So private actually. Again, I believe it's private already, so this is technically not required, right? So what's private means is you don't actually see this, right? Meaning private is actually not, if you are importing from using from somewhere else, you will not be able to use this directly, right? So setters, right? So what do we have public? We have display, right? So for now, right, so this is pretty full example, but again, you guys probably already know this, right? So let's do this. Let's use an animal. So name and age, right? Kind of boring, but okay. So let's use it. Let's use our animal in main, right? Function, right? Main. So dog, and again, of course, this doesn't have to match, right? And this should work, right? We create, right, new instance here. We create an instance animal class as an object, dog, right? Okay, 5 years old. And this is only public method, I believe, right? So why can we do this here? So this is available, this is possible. Above is possible because we created constructor. Yeah, and we'll talk about this in a moment, right? So again, without the constructor, this would not work. So display, right? Let's take a look. So this is our display is public animal class. Again, and notice again dog That's all we have, right? We have this structure actually, but but yeah. So display is the only possible way, right? Make sound, right? Well, we'll add that in a moment. So as a user, as object member function. Object method member function, same thing. Okay, let's see if this works. So GPP, all right, classes on animal or something. I don't know, animal. And it should work. Yeah, name dog. And yeah, animal object destroyed. We saw this. This is actually comes for free here because, of course, this is actually not always needed, right? But you do see this here. Actually, talk about destructors and constructors, right? This actually is done. So here, we of course, you could also say animal object is created. Of course, animal object is created. Let's do that. Let's add that. All right. And we can run it again. Yes, animal object created. Name dog, age 5. Okay, but we'll get all of this in due course, right? So no memory allocated. Semicolon after the closing brace. Yeah, I think it was the case. This is just some basics, right? Animal, class. Yes, you do need semicolon for that, right? So again, so at this moment there is no memory allocation of there are no objects created, right? Again, of course, you're not getting to the statics and things like that yet. Member functions and things like that, and class functions. But no. So 3 categories: private. So again, private is default. So that's the big difference between structures and classes. Again, it's kind of like, so structures are just like classes, but they basically have public access by default. Classes by default have private. So technically, right here, right, this part is not really required. I could just skip it, right? Not so. This is the default, actually. So we can skip it, right? If I do this, right? Again, these are all private. And so, should you include it? I think this is not, it kind of makes it. It's very explicit because you can mix and match. Of course, I think you could also do private afterwards later if you decide something. But of course, you should put them all in the same place, right? So private, yeah. So you can skip it. Let's do this one more time. And how do I test it, right? So it runs, of course. So the main thing is, of course, is that here, right, dog, right, I only have display. So what happens if I decide, right? So this doesn't work, right? So dog, yeah, because set name, right, is private. So basically, so where do you use private members for private ID, right? So this is for internal dirty laundry, all the dirty work inside. So this is stuff that the user of this class, right, should not worry about, right? They only get this limited access, right? They only have, so this is a so-called information hiding, right? If you are using this animal class, again, this class could be coming from somebody else, your coworker, your colleague, or maybe a library, right, somewhere, right? And again, you should not really worry about how to set names at age, right? Basically, in this particular case, right, you only get display in this case. Well, okay, let's do one more. Let's do make sound, right? Let's make a sound. Let's add make sound method. Yeah, animal makes sound. On what kind of sound? Well, we'll add sound here, right? Sound, string, sound, species. Yeah, of course you could add sound, right? Now, of course, we need, of course, setter, right? Again, do we really need to? Again, so what's happening here? This famous this. What's happening here? Who can tell me?
It essentially sets the name field of the object
Yes.
to the provided name.
So it's, yeah, it is a reference to the object, not
Yes.
the class. It's a reference to the object. And again, in Python we call it self, right? It comes from a different language called Smalltalk. But in C++ we use this. Again, it's a reference to itself, to the object itself, right? And you get a nice little arrow syntax, right? So And of course you could add a void, right? Void, set sound. Again, of course, this is going all full-blown OP style, making access modifiers, right? So set sound. So here, of course, the constructor will get. You need to provide age and sound, right? And of course, I miss this part here. Of course, now it's not going to compile, right? Well, is it going to compile? Actually, it will compile, I think, right? Because, well, I'm not using it, right? Let's make sound. Right. So, you notice when I make sounds with these public methods, can I say private? So name, right? So yes, so this name, this age, right? So it's kind of, in a way, it's nice actually, right? So these two, right? Age, right? It's a private, right? But by default, right? There's no name collision, no problems, right? No conflict. You have this. This is kind of nice. You don't have to type this here. That's kind of nice. So let's see about in sound. So what will happen with this part here, right? So sound, right? It's legal. It's legal. Unfortunately, this part is not initialized, right? So things, dragons will fly out, right, of this method, right? So now, of course, I can do here, dog, make. Notice what happened here. I have two. Again, IDEs make you. That's why people use classes. Because when you create objects, you get nice, sort of like documentation built in, right? Assuming you made normal sounding names and make sound does not launch rockets, basically, right? So this will work, right? Well, it will work. Yeah, it's saying it's not good because we did not set sound. It will work, but it will look like garbage, right? It will look horrible, right? So we should set it, right? Let's see what happens now. We're going to break things, right? We're going to break things, and it will, make sound. And this is null. In this case, we are lucky, right? We were lucky. Nothing bad happened. We do it again. Yeah, I think there's no problem, I guess. But make sound. There's no sound. It's actually just null. But we should do it here. We should add it. Yeah, and then we'll get into issue that. String sound is bark, and this is actually legal. Oh yeah, that's legal. That's actually nice. No, this works actually. No, that's very good. The sound is sound, right? So constructor. So the question is this actually required? Are we actually using these methods, or is this implied? Because these are actually not really needed because we have access. Remember, right? So these setters, right? These setters. If I'm going to comment them out, let's see what's going to happen, right? Right. But
well, it should still work.
It should work because this is again we have full access. Remember, public methods, right? And I call them public functions, member functions, right? They have access to private stuff, right? Within. Yeah. So this should still work. Let's try it. And now, of course, my sound will bark by default. My animals start barking. Yes, it makes sound bark, an animal object gets destroyed. So now I'll look at space here, right? So I'll compile it. Yeah, all right. So we learned actually quite a bit here already. We have a default value, which is nice, right? I did not have to break the code, right? So here, let's make one more. Let's make a cat. Let's make a cat. Let's make a cat. Meow, right? So, cat display, and cat of course makes sound, right? Makes sound, right? So this should work again. A different instance of animal class, right? Of course. So, right? Note how. Yeah, so compiling and it's running. Meow, and it is. So notice something here. Animal object destroyed. We destroyed two objects actually here, right? So let's see which one got destroyed first. I imagine it's dog probably, but we'll see. Animal. There's our destructor. Right? Animal project object.
Are destructors called automatically once the?
Yes, you see it here, right? I didn't do anything, right? So of course oftentimes you don't need a destructor, right? It's basically if you have some memory, if you are allocating dynamic memory, then you should use destructors, right? Then you should be freeing memory here, right? Or maybe you have some database connection, maybe you have some network connection. That's when you should be using for destructors, right? To properly finish everything. Because again, most time everything will just continue working fine, but then someday you end up with a huge memory leak, and your program just blows up, keeps going up, right? So yeah, so you should be cleaning up. Basically, destructors are for cleaning up resources. That's any kind of resource you are using, right? That's what it should be. So obviously, there's no need to say that animal object's destroyed, right? That's not really needed in general case, right? It's not required, right? Constructor is also technically not required, but of course you want to initialize some data usually, right? So that's one of the things, right? We get a constructor, right? Because why do we? It's because to have a place where we set up our objects, basically, right? Because we inevitably want to provide some data to objects. So usually we want to provide some data, unless we're using these classes just for functions, for utility functions, things like that, to combine multiple related functions. Like you probably have some data related to this in a class which you want to store in an object. So let me see what animal object is going to be destroyed here. Let's see. We have this. Well, here we go. Quote, and it's going to be so name, right? This should work, right? Still work, yeah. Destroyed. Okay. Yeah. Private. Okay. Let's take a look now. So I'm assuming dog is going to be destroyed first. Well, there might be an algorithm for this. All right. Yes. No. Cat was destroyed first. Interesting. Is this deterministic? So let's try it one more time. Yeah, cat seems to be destroyed first. Interesting. Right. Maybe last in, first out. Maybe there's a stack or some sort of data structure which stores. That would be interesting research. How objects are destroyed. So we see that the cat actually is destroyed first. Very cool. Now let's keep going. We have jumped a bit ahead of the official slides because we are so smart, right? Oh my God! Then we get to UML, right? UML is something which is probably you will see some shades somewhere, especially in large organizations. But this was thought to be like idea was this, that you could graphically write out this class as the members, and then it would be kind of like low code today or no code today. Today automatically generate the code from these diagrams. And needless to say, it did not really work, right? It's used for modeling sometimes, again, in some organizations, but basically this big dream, this is like 20 years ago, 25 years ago, right? You could write this and then it generates the code. Yeah, you could make it like this, right? So sort of like intermediate step, right? There's software. I think IBM developed some other companies, big companies developed it. It's still around somewhat, right? It's unified modeling language. But the issue was this, I think it got too big. If I go to Wikipedia, UML, right? It's huge, right? It tried to provide 94, 95, right? Standard, 97, right? Look at this. Up to 2005, right? And I think it stopped around then, right? So, and the funny thing is, right, that it was, I believe, that the joke was that the General Electric, which is a big company, right, in America, they were really big in the 90s. I think the project failed itself, right? They got too heavy into this architecture stuff, right? Yes, they got too how should I say, too much in love with this diagram stuff, basically, right? And you could keep making diagrams, the project is not going forward, right? You keep making better abstractions, right? It's called architecture astronauts, right? You're trying to make this huge thing, right? But eventually underneath there's no no code, or code is not working properly, right? So yeah, again, so but the thing is, there's still some. Look at all the extras. You can basically use to model many different things. But again, you don't have to use all of it. But some things that UML has been on steady decline since 2004. Visual Studio dropped support, right? So so in a way, as a huge overlapping standard, the good news is you don't have to learn it. However, the basic diagrams, basic ideas, of course, stay the same, right? That you want to write sometimes, larger systems, you will want to use some diagrams, right? You might not follow the specification to the T, right? But you will want to use, not everything can be, things are sometimes better visual, right? Visually developed, right? So that's why, look at this, all these different type of diagrams. They offer a diagram of the diagram, right? They are eating their own dog food, so to say, right? So structured diagrams. There's one which are actually behavior diagrams. Yeah, you've seen probably this one, right? The food critic and chef, right? So something like this you would use. You're meeting with a client, right? You have a big project, right? You try to develop some system. Again, client could be yourself, basically, right? Sort of, internal client, right? You're making startup perhaps or something like that, right? And you want to see what's happening, right? So for something like this are actually use case diagrams. I think are the ones still most often used. Okay, back to what the book talks about, right? Of course, book is through 8 or 9th revision, and when it started, right? UML was all the rage, right? 2018, it is already not so much, but still, it's still around, right? So so again, you don't really need to worry about this too much, right? So my clock and your clock, right? Two clock class, and you have two instance, just like our nice little doggies and cats, right? We have a nice little big class, right? But I can collapse all of this, right? Private. What can I collapse? I guess methods. Methods. I can collapse methods. So again. I'll leave it in here for now, right? Just to be exclusive, just to be explicit, not exclusive, right? So two objects, right? All right. Very similar how the book says. All right. Now, again, so member, right? So dot, right? So thing is, let's make it public. What should we give animals? Only get display, something public for them. And I guess we can do some public data. Let's probably like petting. Let's add a boolean, right? Let's add a public property. And let's see what's on it. Not name, like whether they bite. Right? Right? Bool false. Right, so by default, do not bite. I hope so, right? Is that a safe default? I don't know, right? Assume all animals bite by default. I don't know. A brave assumption. Okay. Now, now of course we should be able to see this, right? So now of course, let's check. Let's now. Does this dog bite? Dog bites. All right. So again, we use the dot access. Again, very well known. Dot. You see now. So again, the beauty of this is public. So you don't see the private stuff, right? It's separate. So information hiding. Again, we have the bytes and and also it's kind of interesting. You can publicly you could also destroy the project here explicitly. Sometimes you want to destroy the objects quicker than actual program ends, right? So, but for now, you can see the bytes, right? So this is public information, public animal biting database, right? So we can see if it's actually bytes or not. Animal, let's see, where's your dog? No, 0, of course, right? Because of course 0 is false. They'll show 0 or 1 for biting. Okay, so of course, again, you can see this property. You probably want to see probably pretty, byte check, right? So again, it would probably move it here, right? And then you do check again. Another approach would be to move bytes to private, and public function would check if any more bytes, right? So that would be another approach, right? So you see the difference, right? So again, so you put all the stuff that you want to do with this data inside the class, right? So you say you want, okay, pay for food, eat for food, drink wine, right? So a restaurant, right? Well, so here you have three objects. You have food critic, you have two persons, and you have the restaurant object, right? So you have to decide where is this going to happen, right? That's one of the issues when objects start interacting, right? How the information is going to be passed, right? Who is going to be doing what, right? For now, it's pretty simple, right? Now, so most of C++ built-in operators. So only two again. So arithmetic, we will get to this. You can create all kind of operators for classes, right? But you need to overload them then, basically, right? And that's one of the difficulties in C++. You can make things, do things you don't expect them to do. Now, with built-in, just like structures, you have two things out of the box, right? You have member access, which is doc, and you have assignment, which of course will copy, right? Copy the data, right? If you assume it correctly, right? Yeah. So you see here, right, that you are, so again in C++, this equality, unlike many other languages, it actually copies the data over, right? Not just a reference, right? So automatic or static, right? So automatic created when the declaration is reached, right? And destroyed when running block is exited. Static created when the declaration is reached. Destroyed when the program terminates, right? Meaning it stays around forever, right? So member of class has the same scope as member of structure. So again, class and structure are almost the same in C++, right? And again, in C you don't have a class at all, right? So member of class is local to the class. You access the class member outside the class by using class object and member access operator dot. Okay, all right. So not too hard, right? So again, you can pass the objects as parameters to functions and return them as function values, right? So if you pass them by values, you actually copy the data, right? Often if your objects get pretty complex, you probably don't want to do that, right? You might just want a reference, right? Of course, you pass by reference, and you have access done, right? And the book actually is correct. So passing by value might require a large amount of storage space and probably too much time for a computer, right? So a reference, you just get I don't say email address, you get a memory address, of course, of the actual parameter, right? Which is, of course, much less memory intensive, right? So, yeah, efficient, right? So, problem when passing by reference, the actual parameter changes when the formal parameter changes, so constant, right? Yeah. Member functions, right? So, now we get to some technical things, right? So, you can write prototypes, right? So, member functions, you can say, okay, I'm going to do it later. Okay, I want to create this cool class, and I want to make sound, right? But I want to do it later. I want to implement it later, right? So you can do this. Let's add prototype for method to type to feed method, right? Void feed, right? So I'll do string food, right? String food, right? Or just so string. I think string is enough, right? Or string food is enough. Okay. And that is it, right? So this means, of course, what's going to happen if I compile? Is it going to complain? I'm not using it, right? To public Is it going to complain? No, it doesn't complain. But of course, if I try to use it, it should complain, right? Cat feed, and I will feed it what? Fish. Oh, thank you, fish. Okay. But unfortunately, now it should complain. I hope. Yeah. You see? Do you see what's happened now? Yes. Undefined reference to animal feed. And actually, in this case, even though it looks kind of ugly, you can already see how we could define. So now, okay, you are back at the code and you say, okay, I came up with all these cool methods, these cool member functions, but I forgot to make them, right? So I defined them. This is completely fine, right? So now, of course, now let's implement. Let's implement feed method. So what do I use? So I use this double. So this, okay. So void animal. So the signature. So signature. The function signature. Your information should be right. Yeah. Unfollow the class definition. Okay, so void, because that's what you wrote, okay, and string food, of course, that's what you wrote, right? So I think you could skip in the prototype, you don't have to say right food. I believe you can skip that, but okay, because you say just string, right? Of course, it shouldn't really matter whether it's named food or kitty food or whatever, right? So, so is fed with food. Of course, here, we could also here we could check whether animal likes the food or not, right? By accessing some private property, perhaps, right? Again, technically there's no difference, right? Whether I make it here, right, at the outside, right, at the end, or whether I do it here, right? Again, for organizational purpose, of course, this is good. And later, when we get to abstract classes, this will be actually the norm, right? So, okay, now let's now feed our what did you give it? Fish, right? Animal name, yeah. And we're going to take a break in a moment. Right now, actually, let's see. Animal, yeah, animal cat is fed with fish, and unfortunately, animal over cat is destroyed. That sounds horrible, actually, right? Destroying cats and dogs, right? But at least the cat got some food before that, right? So, all right. So I'll see you in about what 12:10. Let's do 12:10. So a little break.